Three sections for tonight: log base 10, log base E, and application of them. So we'll start with this one. And if you look at our book, it's really one page in our book. Log base 10 is known as the common log. So a lot of people call common log. The reason we only cover these two, if you look at your calculator, I'll show mine here. There's two log buttons on it. There's LOG, which is the log, that's log base 10. Can you see LOG on your calculator? That's the common log. And the LN, which is log base E, that's the natural log. Those actually can help us solve almost any equation. Some of you might have a fancy calculator that does log where you can write the base and the value there. I don't have that on this calculator. So how do we use it? If I want to find the log of 10, well, I know the answer to that is what? 1. Why? Because if I don't write a base, what's the base assumed to be? 10. 10 to what power is 10? 1. So if I go to my calculator now and I go log 10, now again, it depends. If you have a big calculator, you write the log first, then the 10 second. If you have a smaller one, maybe you want to type the number first, then the log after that. So it depends on your calculator. And it should give you a value of 1. Can't see the 1, but somewhere here. Can only see one or the other. Here we go. No. Reflection too much. Either way, it's horrible. But log 10, I got to keep sliding it, equals 1. Can you see both now? Not really, huh? Just the 1? Yeah, I got to slide it this way to see the thing. Then I got to slide it this way to see the answer. So anyone who's watching on video is going to be sick now. Motion sickness. So you can find the log of 50. You just go log 50. Clear this. Log 50. Again, if I hit equals, and it should give me what? 1.698970084. I can't really tell the difference between 0 and 8 with my eyes. So it might be a little bit off there.
It's 0, 1, 3, 0.
3 zeros? Yep. See, I couldn't tell if that's 0 or 8 there, so that's a 0. What's the log of 426? If you round that, it should be roughly 2.629, right? I'm not going to write all the digits. So if there is no base, it's assumed to be log base 10. Now, if the number is less than 1, remember the graph of the log looks like this. You can't take the log of a negative. You know what? I should have listed the rules here. I'll come back. I'll do it right now. And this is what the log function looks like, the graph of it. Of any log, doesn't matter what, any base. It doesn't matter. If you try the log of 1, the answer should be what? 0. Notice if you pick any number between 0 and 1, this never touches the line, so you can't do the log of 0. This is error. Because the domain has to be bigger than 0.
Because any number to the power of anything cannot equal 0.
Correct. Correct. There's no way you can actually find a number to a power that will make it 0. I don't care if the power is positive or negative. You can't take the log of a negative number. That's domain error. But notice if you pick a number between 1 and 0, your answer should be what? Negative. So the answer to the log can be positive, can be negative. If the number is more than 1, your answer is positive. If the number between 0 and 1, your answer should be negative. So if I say, what's the log of 0.5? It better be a negative number, because 0.5 is somewhere here, and the log of that will be a negative value. Did we get a negative value?
Yes.
Any number between 0 and 1, if you take the log of that, it's always a negative number. What's the log of 0.001? That should be a negative 3. So if the number between here and here, the answer is always going to be negative. If it's more than 1, the answer is going to be positive. Again, I'm going to go back on the second page and write the properties of log. I should have wrote them first, but I lost that thumb drive. It got me all, I don't know, dizzy for a few minutes. Remember the properties of log. Keeping that picture in mind. We wrote 6 properties for the log last time. I want to write them, put them on a clean sheet of paper, so we'll have them. This is the picture of the log function. Again, that helps me when I look at it. Keep that sheet handy. It makes our life easy. What's the first one? It says, rule number 1, last time we said, you can't take the log of what? The log, I don't care what the base is, of a negative number or 0. Rule number 2, the log of 1 is equal to what? Doesn't matter what the base is, always a 0. Rule number 3, how do we write that one last time? If y equals, was it b to the x?
Yep, b to the x.
Then you can go back and forth with this. You can write that log y base b equals to x, right? That's the base b, whatever your base is. Rule number 4. If we have the log of any base of x times y, you can break it down to what? Log of x plus log of y. Rule number 5. If you have division, that's log of x minus log of y. And rule number 6, if you have power, you can take the power to the front and make it a multiplications. Notice all I did, I moved this one, put it in the front. And if I want to add a derivation of this one, if I want to add one more rule, which is part of this one, I call it 6b, because it's really part of 6. If these numbers are the same, these two are the same, your answer is always going to be what? Remember, it's n times log b base b. b to what power is going to be b? 1. So that will be a 1 here. N times 1 is always n. So if these numbers are the same, your answer is always whatever the power is. That's part of this rule. So that's why I knew here when I was playing with the properties here,
Isn't log 0 always going to equal?
can't have log base 0.
Oh, right.
Yep. So when I was playing here with these numbers, I knew the answer is -3. Why? Because I know this number is what? 10 to the power of -3. And I know the base is what here? The base is 10. Once these numbers are the same, the answer is only the exponent, which is what? -3. I knew that. The same thing right here. Once these numbers are the same, what was the power of 10 here? 10 is 10 to what power? 1. That's why the answer is 1.
So how's it different with that last one?
This one, that's 10 to the -3. That's 0.001. That's 1 over 1,000.
Because it's 3 decimal places, it's
Yep.
10 over 3.
-3. Yep. It's 1 over 1,000. What about if we actually give it to you backward, meaning what? If I give you the answer, can you tell me what the number is? So I'm working reverse now.
And some,
So for example, if I said to you log x base 10 equals 3, can you find what x is? Well, that's easy. So I got it. I can use rule number 3. I can change it to exponential. The base, which is what? What's my base here? 10 to the power 3 should equal to x, right? Which means x will have to be what?
1,000.
1,000. Did I have to do that? The answer is no. If you are given the answer and you want to find the number on your calculus, the function right above the log. What's above the log? 10 to the x, that's the inverse. So if I go 10 to the power of, or is it turn on first? Clear. If I go 10 to the power 3 equals 1,000. So if I give you the number, I'm looking for the answer, straightforward. If I give you the answer, I'm looking for the number, that's the inverse function, or the second function on your calculator. So, go ahead. Log y equals 2.4. What is y? You go to your calculator, that's the inverse function. So 10 to the power of 2.4 equals y. Where's my calculator here? 10 to the power of 2.4. 251.19. Log t equals negative 0.024. What is t? T equals what? 10 to the power of negative 0.024. Go to my calculator, second log, negative 0.024 is 0.946. Okay. Where do we use logs? In lots of places, but I know when I'm teaching electronics, we talk about decibels. Your headphone, if you have headphones, the sound, how much you hear, is measured in decibels. So now, power gain. the power coming out of the speakers, is measured in decibel. What's a decibel? Yep. Like if you have really good speakers, they'll tell you the decibels on them. So that's dB. And it's always written small d, capital B for decibels. Usually the decibels calculates measured, the way they measure that, by taking 10 times the log of the output power to the input power. So PO is the output power, and PN is the input power. You get this much power going to the speaker, that much power coming out of it. Let's say we have this speaker here. It's a fancy speaker. What is that? Bose is a good name. There we go. That's our speaker. And this speaker manages, we put a small amount of power going to it, the P input equals 0.625. It's not even 1 watt. And it gets out of it, we can get output power, I'm not going to make it that much, 15.8 watts. This is the power gain, G for the gain. Let's calculate the power gain. So I should write G is power gain. So calculate the power gain, which means calculate G. I have to use that equation. The power gain of these speakers is 10 times the log of power output over power input. What's my output power? 15.88 divided by what? 0.625. So I got to divide the, or I don't have to because I have a calculator. Might as well divide them, make it one number. I can apply the rules of log, yes. But with the calculator, just divide these two numbers. So that's equal to 10 times log. When you divide these numbers, that's 25.28. So now take the log of that, 10 times the log, just type it the way you see it, 25.28, and it's 14 decibels, 14.03 decibels. In electronic, when I graph something, something called body plot for me. Body plot we graph is 20 log. Instead of just graphing the function versus function, the problem with graphing a function versus function, like for example, especially in electronic, your frequency goes from 1 hertz to 1,000,000. You will need a piece of paper the size of Massachusetts just to go 1, 2, 3, 4, 5, 6, 7, all the way to 1,000,000. So what we do, we graph what? We put log on the bottom. Log of 1 is 0. So you start with 0. Log of 10 is 1. Log of 100 is what? 2. Log of 1,000,000 is 6. You go from 0 to 6 on that paper. And you plot the log on the bottom. You can have also log on the side. That becomes log. Or semi-log versus log. By the way, that's one of the topics electronics want us to add to the course. We said, forget it. You can teach it in your class. But that's one of the applications for it. If you just do frequency versus the output there, your frequency can change. You can turn that knob from 1 hertz to 1 billion easily, just with one turn on that thing. That means you're not gonna go on a piece of paper, go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and watch the output. We do the log on the bottom. Lots of application. But this section, really basically, can you use the log button on your calculator? Do you know how to use it? If we give you the number, hit the log button to get the answer. If we give you the answer, we're looking for the number, what number are you gonna hit? What button? 10 to the power, which is 10 to the x. That's the only two keys. That's this section. You'll see the application of them, not in the next video, the one after it, in the section third one. So this is section 13.4. That's it, using the log button. And if, in our book, that's only one page. And if you understood that one, the next section will be probably 5 minutes